Okay, so we have been talking about the different types in that we can work with in Python. So we talked about several of the main types, right? So we started talking about the basic types or the types that holds atomic value, except for the string that is can be considered as atomic because like the entire thing is considered one string, but at the same time has some nature or some sequence nature because it's consisting of multiple elements. And we talk about the collection of data types. So we talk about sequences, the sequence nature of the string, and then we talk about lists and tuples, right? Then the last sequence that we didn't talk about was the range. Okay, so it is kind of a special type of sequence. Before we talk about now all the sequences, actually all collections are considered what we call iterable. So what does iterable mean? It's something that we can iterate over. So we can create a loop that runs over the elements. Okay, so all iterables are considered compatible, and we can convert one from one type to the other. Okay. Now I've been saying when we talk about int to that move to int, I said like not very accurate description. I told you it's a function with the name of the type, right? Well, in reality, it is actually a constructor. So everything can perform the class, and that function that we're calling is the constructor of that class. Okay. So when we say list like this as a function, so list is the name of the class, right? So it's the name of the class. And then when we use the name of the class as a function, that would be the constructor function. Okay? So now here, when we call the constructor and give it an argument, then we are creating a new object that is initialized by this argument, right? So here we're creating a new object of type list initialized by the given sequence that happens to be a string. So what happens is that it takes the element of the string and creates a list based on it. Okay? Now same with the tuple. Okay, it takes the element in the whatever given interval is and creates a tuple based on it. And similarly, converting tuple to list or list to a tuple. Okay. Now the one thing that we need to be careful about is the string. When we try to convert anything to a string, we would hope that it will take the specific elements and put them together in a string, but that's not what happens. When we try to create a string based on anything, it just turns out that thing is false. Okay? So let's say here, for example, we give it a list. Now what comes back in the string, the first character in the string is the square bracket. So the square bracket was part of the syntax in the original list, right? But now it is the first character, the first element of the string. Okay, so let's try this out because it might be confusing. So I'm gonna create a list. Let's call it my list. All right, let's just okay, my list equal 1, 2, 3. Okay, so the first element in that list is 1, right? Is that number 1? This square bracket doesn't have any meaning, it's just part of the syntax. But if I say my list as a string, and then I call the string constructor and give it the list, and then my list R, you see how it looks like? Okay, now if I say my list str of 0, the first element in the string is a square bracket. Okay, The second element would be the number 1. The third element would be the comma. So even the comma is part of the string itself. Okay, if I try to convert that string back to a list, so my list back equal list of my list string. You see how different it is? Now the commas and the square brackets are part of our elements. Okay, so we need to be careful with that. Yes. Yes.
Some with space as a string with some combined when I printed a minus square, like I don't but it just space. But then this like combines with space.
So it depends on how sent it, how to send it. You see the way I sent it. Oh, I just had it in spaces, so it kind of added some spaces internally. It's normally called the two-string method, so it would come as whatever how it normally depends on thing. Your element 3 was not the constant space.
Yeah, it was just space.
Did you say 3?
Yeah.
3, then so that's the fourth element.
Yeah.
Okay, so probably if I try to print the fourth element, it would be a space as well. So element, so index 3, that's the fourth element. Yeah, no problem. All right. Now there is a way that we can take elements of a list or iterable and turn it into a proper string, but that's a function in the string itself. Okay, so here, so there's a string that contains the delimiter. So I want to combine the elements of the list into one string, delimited, like separated by this string. So this in itself is a string type, right? Okay, and one of the functions in the string is called join. So it takes the list and just concatenate the elements of the list separated by the delimiter I specified. So I specified here underscore as a delimiter, so it combines the list with that. Okay. But the constructor itself behaves differently than the other constructors because the string itself is not exactly an exact syntax, an exact sequence. It's a category in its own, but it shares some of the functionalities with the other sequences. Okay. Now the final sequence we want to talk about is the range. This is very similar to you probably learned about it, a similar concept in MATLAB. Okay, so that generates a range of numbers according to the given pattern. So the given pattern consists of 3 components: the starting point, the end point, and the step. Okay, so if we neglect the start and the end, then we are starting at 0. If we neglect the start and the step, then we are starting at 0 and stepping by 1. All right, and then the stop is the last element we don't go for, like the ending number is not included in the range. So if we say range 10, so we didn't specify a start or a step, so the start would be 0 and the step would be 1. So that's a range of numbers from 0 to 9. Okay? Now here's the thing about the range. It's one of the things that we call the lazy function. So the actual numbers are not generated unless we need them. So we generate them when we need them or consume them, and then they discard it. So it's kind of a way of saving the resources. So in order to see the actual number in the range, we need to consume it. So one way to consume it is that to turn it into a list. Okay? But if you try to print the range itself, it's just going to give you the definition of the range. Okay? It's not going to give you the exact numbers, because the exact numbers will only be generated when we need them. Okay? So that's way to save the memory. The numbers are not stored in the memory. Okay, so let's try this out. So I'm gonna define a range. So let R equal range of 10. Okay, now I want to see the numbers in that range. Okay, so I try to print R. You see, it gives me the definition of the range. All right. Now, in order to see the actual numbers, I have to consume it. So I have to cause it to be executed as if I am using it. Okay, so one way to do that is to convert it to a list or to create a list based on it. And in that case, it will be consumed. Okay, but now this list is not stored anywhere unless I receive it in a number, in a variable. So the values of the range after they are consumed, they will be discarded. And every time I use it, they will be generated. Okay, now what if I want to have the even numbers? So let's say even equal range. So I only want the even number, so I can omit, or I can start at 0, stop at 10, and then I want to skip 2 instead of 1. All right, so if I want to see it, I have to consume it. So let's turn it into a list, and there you go. Okay, but if I want to check whether a value is inside a certain range, I don't have to consume the entire range. Like I don't have to generate the entire number. I can just check for the value, and it will see if that value belongs to that pattern or not. So the pattern that we defined here determines whether a value would belong to it or not. Okay, so if I say, let's say, I can check whether 5 in even. Okay, so without consuming it, and it says false because it doesn't belong to this range, to this pattern of the range. Okay, now if I say an even number like 6 in, all right, and not n, obviously is the negation of the n. Okay, now we can check the length of the numbers. So length with one of the functions that apply on sequences, right? So we can check the range, the length of a range. So R itself would be 10, even would be 5. Okay, so all the operations that would apply on sequence, the general operations that apply on a sequence, would apply on a range except for 2. Except for the plus, so the concatenation, and the repetition. Why is that? Because the values in the range have to follow a specific pattern. That's the pattern that we specify with the start and end and the step. And using the concatenation and the repetition would mess up with this pattern. So they are not allowed with the range. Okay? But any other, like you can access an element with an index, for example. Okay, so let's say which element is an index 2 in the even range. Okay, which element would be an index 3 in the R range. Okay, so we can still use the indices, So all other functions work, operations work, except for the plus and the repetition. Okay. Now another thing, again with a string, if you send a range to the string, it will just take the definition and surround it with quotes. So it's not really that meaningful unless you want to have a log or something like that. Okay.